Thank you all. So in my talk, I was charged with looking over a vast literature on the health and environmental effects of shale gas development, and I can't begin to do justice to that. What you're going to get here is kind of a Cook's tour of studies that I know of or participated in or I think are really cool that get into kind of what we know in this area and what we don't. So there are no big databases. I can't make generalizations about the risks associated with shale gas development. I can just point out some key interesting studies. So one way to think about this literature, and I'm not going to dwell on this, but think about these steps. So there's activities in shale gas development like building a well pad. Then these activities create burdens, like the emissions coming out from the bulldozers. And then whatever ththese burdens are, they have a certain degree of toxicity, let's say, if they can get in the environment, but they may not get into the environment. So if produced water goes into a tank and it gets recycled, maybe it never actually gets into the environment. And then even if it's in the environment, it may not expose anything that can be damaged by it. And then if it does expose something, then like a human or a deer or a tree, then it can have impact. And finally, I'm an economist, so what I care about at the end of the day is how much people care about these impacts and we express those preferences to avoid these impacts in monetary terms, so value. That's what I mean by value. And studies in the literature can cover any of these pieces and any linkages between these pieces. And you really want studies that start at the activity, go through each of these steps in the damage function, and give you answers all along the way. And you just never find that. In fact, some of the studies I'll be talking about jump over the entire thing. They start at activity and they do value, but they don't do anything in between. It's all about black box. And other studies do just from the activities to the burdens or various pieces of it. So just keep that in mind as we go through things. So the first thing we did at RFF to try to understand this space is do what I'm calling a risk matrix, and I'll show you that in a moment. I'm going to talk about risks from liquid waste of a variety of steps that you would go through like a process diagram and talk about risks at various stages. It's not comprehensive. I'm going to talk about ecological risks. I'm going to talk a little bit about health risks and what you might call quality of life risks, and then talk about a evaluation study that my colleague and I did. So this is the risk matrix. I guess you probably can't see that here, but those of you who want to see the sort of the big picture about the activities in shale gas development, they're linked to burdens, and where those burdens kind of end up. That's what we mean by a risk matrix. And if you break down this risk matrix to what we call impact pathways, which is that link between activity, burden, and where it ends up, there are 264 of those. So if you kind of work it through, what you want to do is identify the highest priority risks. And we've done that with an expert survey, but I'm not going to go into that today. So starting with the liquid waste, we have a study. It's not out yet. It's in review. And what it does is analyze. I think it's the study that analyzes the largest amount of data that we've seen on what's in the fracking fluid and produced water, the flow back and the produced water that's coming back up. Pennsylvania has a program where the companies have to report this on Form 26R, and we have about 215 samples. The reason it's actually so small a number I could go into if someone wants to know. There's 432 different analytes identified, and it was incredibly difficult. These samples are sent to chemical assay companies, and it's a mess to go through these data. It's very complicated. We had to create our own database basically out of hard copy. And so here's some of the results. But these are general chemicals. So you've got salt, basically chlorides, total dissolved solids, that you can see. The orange is flowback. The clear or white bars are produced water. We have the lines coming across, the horizontal lines are standards of various kinds. And I think the bottom line from all of this, and you'll have access to the slides, whether it's chromium, cadmium, strontium, some of the hydrocarbons, the organics like benzene, toluene, oil and grease, and some of the norms, the radioactive materials. There's really a lot of heterogeneity in these liquid wastes. The mean measurement is very far under even drinking water standards, let alone effluent standards. Sometimes it's quite far above. It depends on the chemical, and there's a lot of heterogeneity for a given chemical across sites. The bottom line is, of course, that even if these numbers are very high, this stuff is not supposed to see the light of day. It's not supposed to get into the environment just the way it is. It's supposed to get put into pits or put into tanks and then treated or put into deep water injection wells or recycled and then ultimately put into deep well injection. But the fact is that this stuff gets out. So this is a different study. This is a study we're doing actually with EDF on pits and ponds and tanks. And this is just some data from Mexico, I think, New Mexico, that shows leak rates from, or actually incidences of leakages. We couldn't get the denominator to get this into rate form. This is a general comment on the lack of availability of data that shows that pits, the blue line, have more leaks than tanks, but there's probably a lot more pits than tanks, so it's really hard to know. But these things do leak, so and they overflow, and hunters or vandals shoot holes into tanks for target practice or for just being malicious. Tanks get blown over in tornadoes. All kinds of things happen, not that frequently. So the materials can get into the environment. This is an example of some of the types of spills that you get. So vandalism here, this 2 over here is where you get the tank shootings. And a lot of this is leaks, overflows from pits, leaks from frac tanks, and so on. So the material gets out there. So we have another study. The question is, once it gets out there, then what happens to it? Is it a problem? And so this is a study that this appeared in PNAS about a year ago on surface water quality risks. So here we have a database. I'll show you the data. This is all the data in the study. I'm just showing it. You can't see all the details, obviously, but what we have is all the wells in Pennsylvania. We know where they all are. We know when they were all spudded. We know where the waste treatment plants are that they were sending their waste to. We know the topography. We know a lot about this, the situation there. And most importantly, we know the water quality monitors in where they are in each stream in Pennsylvania, and we know the readings. So we took total suspended solids readings and chloride readings from those monitors and related them over space and over time to drilling activity and in Pennsylvania statistically. So it was a massive statistical analysis, and what we find is both good news and bad news for the shale gas industry, at least in Pennsylvania. The first thing is good news. We didn't see any statistically significant impact of shale gas development on downstream chloride concentrations. So this is, if produced water is getting somehow into the environment, into these streams, on a everyday basis, we would see this in the statistics, but we don't. It doesn't mean that there are no spills. We know there are spills, but it means that it's not happening on a systematic basis. So that's a good thing for the chloride itself, as well as chloride as a marker for whatever's in the produced water. We did find, though, that the release of treated shale gas to surface water by the permitted waste facilities, so these are treatment facilities, does appear to increase downstream chloride concentrations. So when the waste treatment facilities were getting this waste sent to them, and then they were emitting whatever was left residual after treatment, those high chloride concentrations were showing up at monitors. And Pennsylvania has a voluntary ban on this kind of activity at POTWs, but it's still happening a bit. And then we did find sort of a runoff effect. We did find that a correlation between all the shale gas development activities and site preparation and road building and so on TSS concentrations downstream. So this is just some indication. I'm not aware of any studies that really have gone into it at this level, but it's some indication of what we know and what the problems are. Now I want to say a little bit about induced seismicity. I'm not an expert on this. There are people in the audience who are much more of an expert. We didn't do any studies on this, but I just thought some of the USGS data was pretty interesting. So the first thing is we know seismicity from the fracking location itself, deep underground, is not the issue here. It's in the disposal of that waste in deep injection wells. Deep injection wells are the number three in anthropogenic earthquake causes. There's 40,000 of these wells, and there's been a significant growth in earthquakes greater than 3.0 on the Richter scale since 2009. Now, most of these, the USGS says, these are coincident with oil and gas waste injections, but in certain states and in certain instances, they'll use the phrase caused by. And the data looks something like this. This is for the Oklahoma area. The first thing to look at is the color. The colors. So this is kind of the earthquake hotspot here, and then there's less probability of quakes as you go further. This is just on the basis of the underlying geology. But what we have is swarms of earthquakes around here where there's been a lot of deep injection well activity, culminating in that 5.6 earthquake, which is the highest seismic event recorded that's thought to be associated with these activities. And the orange and the red are post big development activities in Oklahoma, shale gas development activities, where the yellows are this much greater distribution, kind of random distribution, is pre the shale gas development activities there. So that's certainly suggestive. And then USGS also has this graph that shows for this region here, this increase in greater than 3.0 earthquakes. This is just the data behind that statement that I made. And this is too bad. I mean, to the extent this problem can't be addressed, and I'm sure it can be addressed, this would be a big you because the safest place to put these wastes is in deep injection wells. You can take the waste to a commercial waste treatment plant, but they can't get rid of they can't remove all of the contents of those wastes. Now the industry's cutting water flows through reuse and recycling and using less liquids at the front end. So this is one of the ways to deal with it. One of the concerns is that the owners of these kinds of wells are small guys, small businesses, And they may not have the technical sophistication to be able to do the seismic testing and other technical work so that you're pretty sure that putting your waste down these wells are not going to cause seismic activity. I mean, having said all this, there are very few wells that have been targeted for some seismic activity. Still, it's a looming threat. I wanted to show these two slides. This is my ecological slides. It's very hard to find a study that actually links shale gas development activities with actual ecological effects. And this is one study we found. So on the left here, this is an area of Wyoming near Cheyenne. There's very little shale gas development activity here, or oil. It's oil and gas. And then several years later, this is 1999, a decade later in 2009, you can see all of this activity here. And so what they did is they tracked mule deer before and after in 1999 and 2009 to see what their grazing patterns were. And so here's the difference. I mean, yeah, sure, duh. If you have all this activity over here, the deer are going to stay away, and they're going to go over here and over here. Whereas before this activity took place, they were grazing and hanging out, in these areas that are now no longer available to them. And the ecologists make the point that, well, the deer obviously preferred to be in the areas they were in 1999. So they're at less preferred areas now, maybe greater crowding. There could be problems with the herd. So, this is some of the best studies that I've been able to find in this area. Now, going to the health side, we've done some work on truck accidents in Pennsylvania that's suggestive that all of these, this industrial activity that we call shale gas development, with all the trucks running back and forth carrying water and other chemicals and so on, are having an effect on accidents. We wouldn't expect otherwise. And in fact, you can see it in the data. So these two lines here are the heavy line, dotted line are accidents in counties with more than 20 wells in them. And this is the accident rate over time. And then the light dashed line, that's accidents in counties with 20 or less wells, fewer wells in them. Most of these counties have zero. So these would be in Philadelphia and Pittsburgh, where there's just no activity. So you can see a couple things. One is these two lines are going together very tightly. And there's also these accident rates are jumping up and down. So it's a highly variable system. This is before shale gas development really took off. Once that development takes off, which is the solid line here, you can see the breakaway effect on rates of accidents by trucks here versus here. So in spite of all this variability, there seems to be a big signal here. This translates to about 100 excess truck accidents a year. And that has certain mortality and morbidity implications. We're doing more in this area to try to be a little less than suggestive. And finally, I wanted to mention property value study that we did. This is what's taking you from activities directly to values. So property value, if you look at changes in property values, this is what I call a great aggregator of local perceived risks. So people who are living near wells and want to sell, they may want to sell their house and they want to get the heck out of there, some of them, maybe they don't. But if they do, they may be willing to take a lower price for their home than someone further away. And similarly, people who want to buy a home may, if they perceive there's a risk, they're not going to move in there unless they get a big price discount. So we're trying to pick this up. So what do we find? We looked at the effects of both proximity of a house to a well pad as well as intensity, so how many well pads are around. And what we found is that proximity really matters. So if you're within 1.5 kilometers of a well, your house, and you've sold it, and you're on groundwater, so you're on well water as your source of drinking water, you get hit with a $33,000 penalty relative to homes that are further away, but are on, and at the same time are on public water. So you need actually both of these things to create such a big discount on the home. And the obvious lesson here is that people are very concerned about groundwater. This is perceived risks at work. It says nothing about actual risks. It's all about perception. And finally, we found that intensity matters very little, that it's really the action is proximity. And I think I'm running out of time, so I'll just stop right there. Thank you very much.